Hello friends, today I will be delivering lecture on variance ratio test, that is F test. It is useful in quantitative techniques. So what is F test? F test actually it refers to the test of hypothesis which is related to two variances, and these variances are derived from two samples, and these samples are drawn from normal population having the same variance or not. What we study that this hypothesis is true or not, the samples are having the same variance ratio or not. That is what we study. The assumptions of F test is, it is a small sample test. The population from which sample is drawn is normally distributed and the variance ratio must be 1 or greater than 1. So these three are assumptions of F test. Now we will know what is null hypothesis. So hypothesis of this test, that is F test, is formulated which may be either of these two. Two things are there. Either two samples are drawn from the same universe, or the variances of populations corresponding to both samples are equal. That means two equal populations are there. Either one population is there and then two samples are same. So that is why we can come to conclusion that it is drawn from same universe or same population, and otherwise the variances of populations corresponding to both samples are equal. That means two equal populations are there. Populations are different, A and T, but those two populations are same. Now we will understand the formula for F test. F is larger estimate of variance divided by a smaller estimate of variance. The formula will be like this, the same thing. F is S1 square divided by S2 square. The condition is S1 square is greater than S2 square. And if S2 is greater than S1 or S2 square is greater than S1 square, then the formula will be F equal to S2 square by S1 square. So what are these S1, S2 and S1 square, S2 square? S square is variance of sample, whereas S we know is standard deviation of sample. Now question is how to calculate S or S square. So for S square we will be taking some formula. There are two options. First is in question deviations from mean X bar is given or can be found. That means whole data is given to you, you will find mean and you will find dx, that is X minus X bar. Then the sum total of that, and then the square value of that, and then the sum total of that. So S square will be sigma dx square whole divided by n minus 1. So that formula will be applied there. But if standard deviation directly is given, okay, of both samples, then what we will be doing, S2 square is n into standard deviation square divided by n minus 1. That is also called Bessel's correction, because here in numerator they are finding this n and in denominator n minus 1, and then the little adjustment is done here. That is why it is called Bessel's correction. So these two are the methods of calculating S square. Now we will be dealing with type 1 question. The question has two features. Like when two samples are given and they are from the same universe, that will be our null hypothesis. And second, we have to do it without Bessel's correction. That means complete data is given, then there is no need of Bessel's correction in this. That means the standard deviations are not directly given, but data are given and we have to find the things in that. So these are the things that can be given in question: sample X and sample Y, or sample 1, sample 2. We have sample 1, figures are there and the serial numbers are there, so that means N1 equals to 10. On the basis of that, we have found sigma X is coming to 160 and X bar is coming to 160 by 10. I should have written x bar sigma x by n1, that is 160 by 10, and that is 16. That is first information. The second sample, now in the first sample itself, because our x bar is coming to 16, so we will be taking deviations from mean. That means dx. Dx will be 17 minus 16, 18 minus 16, and it goes like that. Earlier also we have studied that in other units, in other videos. So sigma dx will be coming to 0. That means our mean, whatever we have taken, and the calculations, they are right. And then we are coming to sample 2. Sample 2 is y, that is having 12 numbers in the sample, that is n2 equals to 12. And then the y is sample score, that is also given in question. In question this thing will be given to you and sample 1 will be given to you. And on the basis of that we have found sigma y is coming to 180 and n is 12. So y bar will be sigma y by n2, that is 180 by 12, that is 15. So I had already taken that for your calculation sake, for your explanation I am writing here also the important information. So dy will be y minus 15, that is deviation from mean, 16 minus 15, 14 minus 15, it goes like that, again it is coming to 0. And after that we will be taking dx square and dy square. Dx square could have been taken here also and here also, because our problem is related to dx square and dy square more. So I have written it in this frame. So dx square will be 1 square, 2 square, 1 square, 2 square 4, 4 square 16, like that, and sigma dx square is coming to 50. And then dy square, so dy square will be, this is dy, 1 square, 3 square 9, 4 square 16, 0, 2 square 4, and the total of dy square is coming to 70. So the important information before us is n1 is 10, sigma dx square is 50, n2 is 12, sigma dy square is 70, x bar is coming to 16, y bar is coming to 50. And our null hypothesis is both the sample are equal. That means variance, standard deviation 1 square and standard deviation 2 square, variances are equal. So we will be solving that in the other frame. Now we have got certain information through analysis of complete data. In your question, only these data may also be given. Okay, on the basis of that you have to do n1 dx square 1, dx square, n2 and dy square. So on the basis of this data now we are going ahead with the question. Our null hypothesis is both samples are equal and derived from same population. That can be denoted with this as h0 is standard deviation 1 square equal to standard deviation 2 square. Now s1 square will be sigma dx square by n minus 1, sigma dx square we know, n1 also we know, and on the basis of calculation we have got 2.35 as s1 square. s2 square will be whole root of sigma dy square by n2 minus 1, sigma dy square we know 70, n2 we know is 12, 12 minus 1, that comes to 2.52. And now one thing we have to take care, whichever is higher that will go in the numerator side. So it will be f will be s2 square by s1 square, and that is coming to 1.073. And this 1.073 will be your calculated value of f. Now we have to find the table value or critical value, as they say, through table. In table, I had explained in detail in the earlier video of t-test how to find these things, these critical values in the table. In f, what happens? This horizontal parameter is of degree of freedom of numerator, that is coming to 11 because 11 is our case, and degree of freedom of denominator, that is 9. 11, how 11 comes? 12 minus 1 is 11, and 10 minus 1 is 9. Numerator will be always numerator side will be the greater side. The greater means dx square will be greater in that side. Seeing the table, we have got the critical value, that is 3.18. Now the thing is, here we can write in this way: v2 equals to 12 minus 1, 11. 11 is numerator. v1 is 10 minus 1, 9 degree of freedom, that is denominator. And on the basis of that, now we will be finding our table value. Table value is coming to 3.18. I have written here also in this 11 and 9. You can see the table. 3.18. Calculated value 1.073 is less than 3.18. That means calculated value is less than table value. That means our null hypothesis is true, that both the samples have been derived from the same universe. So this is the type 1 of F test. So this is the first type. And one thing, in the table generally F, because it is two-dimensional table, only 5% and 1% score of critical value are given. Okay, so there is no chance of so many percentage. So we have taken in this case 5%, and mostly 90% of the time you will have to take in the 5% critical value of F. Now in the second type, we see whether two populations are equal or not, and here Bessel's correction is needed because of the given informations. For example, I have taken a question, hypothetical one, that we have to find F.05 and we have to see that the populations are equal or not. And we have got sample size of the two populations, that is 1731. Marks are there. Suppose it is marks of quantitative technique of two institutions or two universities. So marks are 75 and 87. Sample variance is 50 and 60. So this is question. So our null hypothesis will be variance of two populations are equal. That will be our null hypothesis. The given information n1 17, x bar 1 75, standard deviation variance square, that is 50, and b also we are having n2, x bar 2 standard deviation 2 square, that is 60, and x bar 2 is 87 and 2 is 31. So Bessel's correction we need to do. What we do, we divide it by n1 minus or n minus 1 you can say, and multiply with n. So that itself will be correcting the things. The difference between S and standard deviation this side, that difference will be achieved by us, the corrected one. So S1 square is n1, this whole divided by n1 minus 1. S1 square we have got 53.125 on the basis of this formula. Likewise we have done in S2 square, and that also we have got 62. Now our variance ratio is S2 square by S1 square. As we know, the larger estimate is taken as numerator. So S2 square by S1 square, that will be 62.00 by 53.125, that is coming to 1.167. That will be our calculated value of F. And now to find the critical value, denominator side we have taken, that is 31 minus 1, that is 30 is numerator, denominator 17 minus 1, that is 16 is denominator. And when we find table, then we got the value of F is 5.2. 5.2 is calculated value, is table value or critical value. That itself is called critical value. So as we know, 1.167 is less than 5.20. That means calculated value of F is less than table value or critical value of F. So therefore the null hypothesis, that is two populations are equal, is true. Our null hypothesis, our assumption is true, and that is going to be our conclusion. So this is the second type. It deals with two populations, whether they are equal or not. In the earlier we had studied two samples, whether they have come from same population or not. So these are studies of F test, and after that we will be coming to Z test and then chi-square test in my upcoming videos. Thank you very much.